Astronomers discover fossil galaxy 3 billion light-years away. A galaxy that has remained unchanged for 7 billion years, a rarity in the universe, has been observed by astronomers, offering a glimpse into cosmic history and adding to an enigmatic collection of objects called relics or fossil galaxies. These space oddities are galaxies that, after an initial phase of intense star formation, escape their expected evolutionary path. While other galaxies expand and merge with one another, the fossil galaxies remain virtually inactive. Like celestial time capsules, they provide a snapshot into the ancient universe and allow astronomers to examine the mechanism of galaxy formation. The newly discovered fossil galaxy, named KIDS J08 for Dipluso 059, is about 3 billion light-years from Earth, making it both the most distant and the first of its kind observed outside the local universe, the region of space closest to Earth that is approximately 1 billion light-years in radius. It was found by a team of astronomers led by the Italian National Institute for Astrophysics (INAF), using high-resolution imaging from the Large Binocular Telescope in Arizona. Relic galaxies, just by chance, did not merge with any other galaxy, remaining more or less intact through time, said Crescenzo Tortora, a researcher at INAF and first author of a study on the finding published May 31st in the journal Monthly Notices of the Royal Astronomical Society. These objects are very rare because, as time goes on, the probability to merge with another galaxy naturally increases. Very compact, very massive. Astronomers believe that the most massive galaxies form into phases, according to study co-author Chiara Spiniello, a researcher at the University of Oxford in the UK. First, there's an early burst of star formation, a very quick and violent activity, she said. We end up having something very compact and small, the progenitor of this relic. The second phase, she added, is a protracted process during which galaxies that are in close proximity start interacting, merging and eating each other, causing a very dramatic change in their shapes, sizes and star populations. We define a relic as an object that missed almost completely this second phase, having formed at least 75% of its mass in the first phase, Spiniello explained. The telltale feature of fossil galaxies is that they are very old, compact and dense, much more so than our own galaxy. They contain billions of stars as massive as the Sun, and they are not forming any new stars. They're doing essentially nothing, and they are the fossil records of the very ancient universe, she said. They formed when the universe was really, really young. And then, for some reasons that we honestly don't understand yet, they did not interact, they didn't merge with other systems. They evolved undisturbed, and they remained as they were. Fossil galaxies are crucial because they are a direct link to the massive galaxy population that existed billions of years ago, said Michele Capillari, a professor of astrophysics at the University of Oxford who was not involved with the study. As living fossils, they have avoided the chaotic mergers and growth that most other massive galaxies have experienced. Studying them allows us to reconstruct the conditions of the universe in its infancy and understand the initial bursts of star formation, he said. What caused these galaxies to stop forming stars so abruptly is a major question, he added. Evidence from both local and distant observations suggests that feedback from supermassive black holes may be responsible, Capillari said. These black holes can produce powerful winds that expel or heat the gas in a galaxy, preventing further star formation. However, this remains an active area of research. An uncertain future. Scientists initially identified KIDS J08 for Dipluso 059 in 2018 using the VLT Survey Telescope (VST) at the Bernal Observatory in Chile. That observation revealed that the galaxy was populated by very old stars, but only provided an estimate of its mass and size, so a more detailed observation was required to confirm it was a relic. The Large Binocular Telescope used for this confirmation can render very sharp images due to its ability to compensate for atmospheric turbulence, which otherwise can make it difficult for Earth-based telescopes to focus on distant objects. The newly found fossil galaxy joins a group of only a handful of others that have been observed at the same level of detail, the most pristine of which, called NGC 1277, was confirmed by the Hubble Space Telescope in 2018. NGC 1277 and KIDS J08 for 2 plus 0059 are very similar, but the latter is much farther away from Earth. It fits the definition of fossil galaxy almost perfectly, according to Spiniello. This is what we call an extreme relic, she said, because almost all, or 99.5% of its stars were formed incredibly early on in cosmic time, and the galaxy did absolutely nothing thereafter. The fossil galaxy has stars and planets, just like our own galaxy, but it is much more dense, Spiniello added. There will be many more stars in a tiny volume, so it'll be super crowded, she said. And it will be much harder to find solar systems like ours, with many planets orbiting around it, just because of the chances of getting companion stars interfering nearby. KIDS J08 for 2 plus 0059 looks to observers like it did 3 billion years ago, because that's how long it takes for the light coming from the galaxy to reach Earth. Spiniello hypothesized that the relic will likely remain, as it is forever, but scientists can't be certain since they still don't know what keeps it from interacting with other galaxies. There must be something that prevents them from merging, but without knowing what, we cannot really predict what's going to happen in the future, Spiniello said. 1 in millions, it is very hard to identify fossil galaxies and confirm their nature, partly because they're relatively rare and small compared with regular galaxies such as the Milky Way, according to Sebastián Camarón, an extragalactic astronomer at the Universidad de La Laguna and the Instituto de Astrofísica de Canarias in Spain. The confirmation of a distant relic galaxy is a credit to the search strategies used to identify these objects and of modern instruments, he said. Relic galaxies are mysterious, added Camarón, who was not involved with the study, in an email. The fact that a few galaxies are nowadays untouched relics of the first large galaxies needs an explanation. Astronomers can't say for certain how rare relics are, but Spiniello estimates there might be 1 in millions among all the galaxies in the universe. The INSPIRE project, which aims to find and catalog fossil galaxies and spawned the discovery of KIDS J08 for 2 plus 0059, has already identified several dozen other candidates that are in the pipeline for further scrutiny, Spiniello said. New instruments could make this search even more effective. Both Spiniello and Tortora are excited about Euclid, a European Space Agency telescope launched in 2023 with the goal of exploring dark matter and dark energy that will also be useful for observing fossil galaxies. Euclid will be transformational, Spiniello said, because rather than observing one single object at a time, its wide sky survey configuration will cover a lot more. The idea is to find all the galaxies in a patch of sky and then isolate all the ones that are ultra-compact. And if you do that, then you can actually estimate how rare fossil galaxies are. Confirming relic galaxy KIDS J08 for 2 plus 0059 at such a distance is a remarkable achievement, and the future of this field is very promising, Capillari said in an email. With powerful new telescopes like James Webb and Euclid, which produced its first images just a few months ago, and on the ground with advanced adaptive optics, we can expect to find and study more of these relics at even greater distances.